started. It'll be posted to our YouTube channel shortly after, probably later this afternoon or first thing tomorrow. We're really pleased today to welcome three different innovators in the natural gas space, and I hope you enjoy the presentation. And I'm really hopeful that we'll be able to make all the technology switches that we need to as we go through this. But I'm assured that each of our presenters is our old hands and experts at Zoom. So here we are in the virtual world of Zoom. And our first presenter today, we'll just go in order of what you see on the screen. I'll do a quick introduction. I'll go over a couple of logistics, and then I'll turn it over to our presenters. But our first presenter today will be Rita Hansen. Rita's the CEO and a co-founder of Onboard Dynamics. She'll tell you a lot about her company. Hopefully you all had a chance to read these bios, because I don't want to spend a lot of time reading the bios today. So just wanted to introduce these folks. Edson Eng is a principal and co-founder of G4 Insights. And again, Edson will tell you about their technology. And Doug Staker is the Vice President of Business Development for Carbon Quest. And each of these companies that you're hearing from are working on cutting edge technologies, some already in operation, others on the cusp of being commercial and in operation. And we really look forward to hearing more from them as we go on. And I need to be able to change my slide. There we go. So we're not going to have a webinar in December. Hope you enjoy the holidays this year. Couple of comments for everybody. If you're not muted already, we'd appreciate it if you'd mute your phone. If I start hearing background, I'll just mute. I'll look for who you are and I'll mute you myself. But hopefully you'll take care of that for yourselves. If you have questions, please feel free to use the chat function. That's where we want them, so we can keep people on mute and minimize the background that comes with coming off of mute. So again, use the chat function to ask your questions. I mentioned earlier that we are recording this webinar. It'll be posted to our YouTube channel afterwards. And this has a link to a publicly available slide deck, will be made available later. That'll be really up to the presenters. If you want to see some version of their slide decks, feel free to contact me. I will contact them, give them your information, and they can interact with you directly in that regard. So with that, Rita, I'm going to stop sharing my screen and allow you to take it from there. I think you know how to do the share screen deal. It
should be up right now, right?
Perfect. Yes.
Okay.
It is indeed.
So, yeah, this is a sign of the times that this is not my first rodeo on this. Right. So I'm good to go.
You are good to go.
Awesome. Well, I just want to thank the Northwest Gas Association for giving me this opportunity to share our company's story and the innovations we have been working on and the ones we're still working on over the past few years. I think the last time I presented here in this venue was September 2017. So we've made a lot of progress. And a lot is kudos to some of the folks that are on the phone today. So I am Rita, CEO, co-founder. I'm actually logged in here at Sunny Bend. You can kind of see the sun shining through the window. But as many of you know, we spun out of Oregon State University in 2013 and then secured funding from ARPA-E, the Advanced Research Projects Agency for Energy. And really at the time, it was to develop natural gas compression technology that would solve a critical lack of refueling infrastructure for natural gas vehicles here in the US. So, you know, and at that time, I also believed that the technology held the keys to how we can transition from, as you can see, 43 billion metric tons of CO2 equivalents of global emissions to net zero. So today, we are that company that is helping our customers receive economic value and achieve critical environmental benefits using our technology, all at a scale that's been underserved to date. So we're doing this through multiple applications. I'll walk through this, what we're doing today in the transportation and natural gas utility industries by compressing natural gas in a unique patent pending way without electricity and providing mobility, scalability, and deployability for on-site CNG refueling, but to also provide solutions for the natural gas industry and other applications. And then I'm going to talk about where we're going with our platform. So in a nutshell, our technology puts the C in CNG, so compressed natural gas, whether it's conventional geologic based or better yet, from a renewable source. So we have this unique, cost-effective, patent-pending solution enabling a low-pressure natural gas source to be compressed up to 3,600 psi, all integrated within an engine. And it just really means that the system runs on natural gas to compress natural gas with no electricity or diesel required. And this really is our key differentiator and our significant value proposition with our customers. So the first product to market, which happened, we launched in late 2018. First customer right out of the chute was Northwest Natural. So I always have to mention what a strong partnership we have there. They were our first commercial early adopter for the Gofill CNG 80. And our newest product, launched in July, also in partnership with Northwest Natural, is called the Gofill Refueler. So it's a standalone trailer that incorporates a dryer and a dispensing system for refueling up to 4 vehicles at the same time. And this was a product totally driven by customer demand. So when the Gofill is packaged with the GoFlow compressor, it becomes a complete natural gas refueling station, all without electricity and mobile. So just a little bit closer look under the hood, so to speak, of our system. The core compressor platform is based on a V8 industrial engine, whereby 4 stages of compression are performed by one bank shown here and powered by natural gas using the other bank. So interestingly, I used to have a slide here listing in text all the potential applications. So it's pretty exciting for me to now show actual pictures of our technology in the field, performing those applications for our 2 current target market segments, which is utilities and fleet operators. So what you see here on the left with our utilities are filling of tube trailers, backing up of electric driven CNG stations, performing pipeline evacuation of natural gas so that it's not flared during a pipeline operation application. Shown on the right are pictures of fleet refueling of school buses, waste haulers, and in the bottom left, you can see a Hyliion CNG EV hybrid Class 8 truck being refueled by a GoFlow and Gofill. So this specific project is part of the Northwest Natural Truck Loan Program, and we're just honored to be part of this program to demonstrate on-site refueling. And I just have to say, for this particular application this summer, we showed up at 10 a.m. in the morning with the GoFlow and the Gofill system, and by 3 p.m. we were refueling that truck with their local natural gas supply. So pretty easy and convenient for on-site refueling. We call it CNG in a day. For the waste hauler shown in the upper right, and this is going to touch on renewable natural gas, we commissioned this independent waste hauler in Southern California within the South Coast Air Quality Management District last summer. So he is our lighthouse account for the other waste haulers in the region who are under a mandate really to convert to an alternative fuel. So he is saving $1,000 per truck per month in fuel costs alone for his 12 trucks. So 12 grand a month in savings. By using renewable natural gas, he's reducing emissions by 22 tons of CO2 equivalents per truck each month. So that's a really motivating aspect of what we're doing. So that is what we sell today. And really the ability to perform compression the way we do just brings us so many opportunities where that's important. And we're now seeing it's going to open up even larger markets beyond refueling and utility operations, which is why I'm here today to talk about the new innovation, because as part of our product roadmap going forward, we are going to be incorporating cleaning and conditioning capability on the front end of our core compressor platform. And this will allow us to go after renewable natural gas and flared stranded gas applications in a big way. And these applications are already coming to us. So this is a solution to a methane problem that is ever growing. And since our product launch, customers and industry have been approaching us, asking us for this product that combines our unique natural gas compression platform with this upfront gas cleanup and conditioning capability. And it's really to go after biogas, capture that biogas from agricultural operations, which is where we're targeting, and to capture flared stranded gas from oil and gas wellhead sites, all at our scale and not requiring electrical service. So we were invited to submit a full application to ARPA-E, once again, under their newly announced scale-up funding opportunity for this new product. And that new product is a new integrated methane treatment and compression system that would meet this established criteria listed here, meaning it's going to be able to go after a scale of underserved applications that are generating 100 to 100 MCF per day of gas. It's also going to be electric and diesel free. It will be mobile on a self-contained flatbed trailer, and it's going to produce fuel grade methane that can be used for either local NGV refueling or transported via tube trailer to a pipeline or to be sold into other markets. And it will be cost effective. So we expect to hear about this proposal in the next 30 days. We actually secured 14 letters of commitment and support from commercialization partners and industry players for the development of this solution. Some of you who've made those commitments are on this webinar today. I know that. And we already have 2 demonstration sites committed, both on the dairy side here in the Pacific Northwest and on the oil and gas side in Texas. So our timeline on this fully integrated system, once we get notified that we're moving forward, would be actual deployments in 2022. So it's basically a year to get the funding in place for this product development and to do the engineering and build out the first systems. And we're targeting 4 demonstration sites, 2 on the RNG side and 2 on the oil and gas side. So since there might be customer prospects on this webinar, I would be remiss if I didn't talk about what we're selling today, our current product offerings. So we are, as many of you know, we're actually in a direct sales capacity. We're selling our compressor, we're selling our refueler, we're selling it as a package, but we also are offering leasing and compression as a service opportunities and service and support contracts and cloud-based data management packages based on the back-end data collection capabilities that we have built into the product. And just as a go-to-market, just want to, since you're kind of part of my local support ecosystem, we have received significant US interest and also international interest. I have to tell you that I was this morning talking to somebody in London, and yesterday I was corresponding with somebody in India. So, but we're focused here in the US right now on transportation refueling and supporting natural gas utility operations through our methane mitigations. But we really are super excited about the fact that we're on people's radars outside of the US. And we are going to be deploying our first compressor into the Canadian market with our partner in BC. And through our contract with NRCan, we're actually getting support to get all the certification requirements to be able to deliver that system. So that's super exciting for us. So it's US first, Canada second, and I'm thinking it's Mexico and Latin America after that, but India's got such a strong pull as well.
Rita?
Yes, sir.
I have a question that's been submitted from Dave Hawk and it's assuming several several tubes on a truck mounted trailer with 1 million cubic foot capacity under pressure. How long does it take for your compressor to load 1 million cubic feet in these tubes, and under what pressure can you do it?
Oh, that's a really good question. I am going to 1 million cubic feet. So if we're like, so that's 100. I think that, do I have Jeff on the phone, or is Jeff on? I'm going to see if Jeff is, we might have to get back to him on just
Okay.
doing the math, but we're loading it into the tube trailers at 3,600 PSI.
So pressure's 3,600 PSI, and we'll
Mhm.
get back to Dave
On the time. Yeah.
on the time
On
to
the
load.
time to fill. Right.
Great, thank you.
But that's good, and I'm almost done here, so then we can certainly open it up to other questions, because I really just wanted to show a slide of the team, and I believe that Jeff and Todd and Heather Smercina, who's our business development lead in Texas, are joining me today. And I always tell people we're like the seasoned veteran management team that have kind of been around the block, but we definitely have demonstrated the ability to execute over the years. So with that, I'm just going to wrap up my portion of the presentation and turn it over to the next company. I just want to leave you with these thoughts about the industry and our role, as I see it, in the energy transition that is occurring right now. So it's all about, practical, economical solutions, but also with a focus on and a lens on the environmental impacts that we're making. And I think homegrown innovations are needed now more than ever. So a big plug to homegrown. Thank you again to Northwest Gas Association.
Yeah, thanks, Rita. Any other questions for Rita while we switch up screens here? I'll give it just a minute. So I'm going to stop your sharing, Rita.
Okay.
And then Edson, I assume you know how to share your screen. Green button down there at the bottom. Do we have any other questions for Rita? Anybody typing one in? Your screen is up, Edson. We have success.
Great.
Okay. Yeah, go ahead, Edson.
Ready to go? Great. Thanks very much, Dan. Appreciate the opportunity to talk to the group today. We'll be going through the company technology for renewable natural gas from forestry biomass is what we've been working on. So G4 Insights is based in Burnaby, BC, and our team previously worked together at a company called Questair Technologies, which is probably better known now as ZVEC. And at that company, we developed pressure swing absorption systems for gas purification, which includes examples on the left. The large equipment is a steam methane reformer that converts natural gas into hydrogen. And then the Questair system would purify the hydrogen to 5/9 purity. We also developed advanced systems for scavenging hydrogen from fuel lines from refineries, so that you could upgrade the low percentage hydrogen back up into high percentage hydrogen. And one of the other things we found in that market was that we could also use pressure swing absorption for purifying methane from landfill gas and digester gas. And I'm sure we'll have a follow-up chat with Rita for some of the opportunities that she's pursuing as well. But that's in the past. What we found was that methane, if you can make it a pipeline grade product, did have an immediate and large and growing market for renewable natural gas with gas utilities. One of the challenges we found was that a lot of the existing sources being landfill sites and digester opportunities are already actively pursued. The big sites are probably already done, and that the feedstock opportunity was going to be diminishing over time. So in our current company, G4 Insights, we didn't want to pursue further technological development in those feedstock types. What we are focused on is the next feedstock opportunity, which would be primarily forestry biomass. So when the forest industry goes out to harvest trees for making lumber, the tops of the trees, the branches of the trees, all of that is left behind as roadside debris, generally just gathered and burned. And then at the mill site, there's the mill waste from the sawdust, the bark and the other materials that are left behind. Sometimes it's used for pellets. Sometimes the quality is not good enough for that even. So it's, again, it's just a waste product. And what we do in our process is a little different than what some of the other technologies being developed for that is, in that the more conventional approach is to take the biomass and gasify it. That means to heat it under quite high temperatures, like 800-900 degrees C, to create a syngas, which is primarily hydrogen and carbon monoxide, and then convert that into methane using the methanation process. That process is generally quite complex and quite expensive, because the syngas needs to be a very clean, tar-free product that doesn't follow up some of the catalysts in the methanation step. So those pursuits are still ongoing by a number of companies, mostly in Europe, and it's proven to be quite challenging and quite expensive when it comes to the RNG product. What we did is that we looked at the landscape and we found an entirely different approach. So it's a proprietary approach that we call Pyrocatalytic Hydrogenation, and it's based on fast pyrolysis. So the steps involved here is that first is the biomass, the waste product is collected at site. So where you're harvesting trees, we would take the tops and branches, we would chip it and then transport the chips to a central location, likely co-located with sawmills, where the collection area is the shared collection area. We're using a part of the tree that's not being used by the sawmills. At that site, we would then hammer mill it using commercially available hammer mill equipment to break it down to roughly 5 millimeter particles. The first step is fast pyrolysis, where we're flash heating to much lower temperatures that basically vaporizes the wood but doesn't make a syngas.
Hey, Edson.
Go
Edson,
ahead.
can I interrupt for just a moment? I think
Yep.
your mic wire is rubbing up against your shirt there, and so we're getting some background noise as you're talking.
Great.
So it'd be great if you.
Yeah, I'll just
That's perfect. Great.
Oh,
Yes,
sorry about
much.
that.
Thank you.
Great. So the fast pyrolysis creates a pyrolysis gas, which then is combined with added hydrogen, and the combination of hydrogen, the pyrolysis gas, and a catalyst will preferentially form a methane-rich gas. From there, we purify the methane up to a pipeline grade spec, so typically 97-98% methane plus remaining hydrogen, suitable for injection into the grid for distribution. I mentioned there is hydrogen in the process, and the hydrogen is made internally through a steam methane reformer. So this is technology is well proven, and we use as a feedstock, instead of fossil natural gas, we're using some of the methane that we're producing. So a portion of our product is used as a feedstock to make the hydrogen. And then instead of using the methane for the burner portion of the steam methane reformer, we want to keep as much methane as product. Luckily, we have a solid fraction from the pyrolysis step, which is biochar. So we use the biochar in the burner. The spent char produces bioash, mineral-rich substance you can use for fertilizers, or just landfill it, or return back to the forest. The flue gas from the burner is CO2, but it's carbon neutral because it comes from biochar, which in turn comes from the trees. So this process, end-to-end net energy conversion, is 70%. That is the energy in the wood going in. 70% of that energy is available as a methane product to the pipeline. And the renewable natural gas is about 80% lower carbon intensity compared to fossil natural gas. If you use it for transportation fuel, it's about 85% lower carbon intensity compared to gasoline. So that's our technology. And at a commercial scale, our next project we're targeting at the commercial scale, we believe entry-level size is roughly about 36 dry tons of biomass a day. Output from that unit would be about 450 gigajoules a day of renewable natural gas. CapEx roughly 20 million, and selling price for the numbers of work is about the current renewable natural gas in North America, and in Europe it's about can be up to double that. So that's a worthwhile entry point is at that scale. Where we want to get to in North America, of course, is that we do have larger forestry operations, and sizing something that matches the available residue from a typical larger North American sawmill, there's about 750 dry tons a day of biomass available. And that would produce about 10,000 gigajoules a day of renewable natural gas. CapEx for a larger plant like that is about 140 million. And because of scaling, we can actually still make money in the sort of $12 to $15 a gigajoule range, which is extremely competitive, especially when you consider the scale which we're producing this. So instead of poking many, many holes for small biogas plants to inject into grid, you're putting essentially a wellhead size injection for each of our large plants. So it's very attractive for the gas industry and of course the investors in the plants. Where we're at right now is that our most recent demonstration was with ATCO Gas, the major gas utility in Alberta, Canada. We finished that up late last year. It's a trailer mounted piece of equipment, which is suitable for demonstrations, but the commercial units will not be trailer mounted, be large plants. The scale we operate is about 100 kilograms a day of biomass input, and we produce about 1 gigajoule a day of renewable natural gas. That gas was injected into the Edmonton gas grid, so that was the sort of an end-to-end demonstration. And a few years ago, I believe it was back in 2015, we also did a similar type of demonstration in California, in Placer County with the California Energy Commission, where we produced renewable natural gas from forestry residue and actually fueled an unmodified CNG vehicle owned by Placer County. Some of the other applications that we have for this technology is that in the previously I described that we can make renewable natural gas, and we also needed hydrogen as part of that input. What we can do in power to gas, and where this comes into play, is that with the growth in wind and solar projects, there's a lot of overproduction of renewable power when the wind's blowing, the sun's shining, and it doesn't match the usage profile. So the utility industry is looking at things like storage of that power, whether it's batteries or flywheels, compressed air, pumped hydro. Some of the larger scale opportunities is to convert that excess grid power, renewable grid power, with electrolyzers and make hydrogen. And then the hydrogen could be used for end uses like fuel cell vehicles and things like that. But in the meantime, you could also use our technology to convert that hydrogen into renewable natural gas. And the platform to do that is exactly as I described before, except we don't need an internal supply of hydrogen because we'll use an external supply of hydrogen, and that displaces the need for steam methane reformer. It also reduces the need or eliminates the need for us to actually sacrifice some of our methane as the feedstock for that hydrogen. The result is we double the output of the renewable natural gas produced. So we can get 20,000 gigajoules a day from the same amount of biomass going in. And to give a sense of the scale of which we're able to offload the excess grid power, one of our large plants would use about 190 megawatts of power to produce the hydrogen on a steady state basis. But the peak period that you want to draw this excess grid power is about 8 hours of the day. So during peak times, it's about triple that. So imagine 600 megawatts of excess grid power coming off the grid to make the hydrogen and then into a single large RNG plant. So that's a lot of storage. In this case, it's transforming low or negative price power into a high value CNG or RNG product. So that's power to gas. Another application for the same technology is green hydrogen. Right now, it's RNG focused for the industry. Most of the roadmaps, whether it's North American or Europe, they foresee a very large growth in hydrogen. A lot of that's driven by the wind and solar opportunity that I mentioned previously. But we can also participate in that by combining biomass and conventional steam methane reforming technology. So I'll describe this green hydrogen concept. We take biomass, we use the G4 technology to make renewable natural gas and a biochar. That gets fed to a steam methane reformer where the feedstock is not fossil natural gas, but renewable natural gas. The burner is being fueled by biochar instead of methane. the output of the burner, the flue gas, is no longer a greenhouse gas because it's biochar going in. So you don't need to chase the CO2 in the flue gas, which is very difficult and expensive. The output is a hydrogen-rich gas from the reformer. It goes into a G4 gas separation system, which produces two streams. One is a high purity hydrogen stream, which is green hydrogen. At the same time, we're able to isolate the CO2 stream from the reformate, such that you have a low cost, high purity CO2 stream available for sequestration. So you can get negative carbon intensity green hydrogen using this technology. And the last example is blue hydrogen. So it's similar approach, but the twist here is that we're using fossil natural gas into the steam methane reformer as the feedstock. However, on the burner for the steam methane reformer, we're using renewable natural gas produced using the G4 process. The burner gas, flue gas rather, is carbon neutral because it's a renewable natural gas going into the burner. There's biochar being produced that is not being utilized, so that sequesters carbon. The reformer outputs the reformate into G4 gas separation unit, which produces, in this case, blue hydrogen, so high purity blue hydrogen, which means it comes from fossil fuel origins, but it's low carbon intensity. At the same time, we're capturing CO2 from the reformate stream available for sequestration. So in this approach, we're also producing low carbon blue hydrogen with negative carbon intensity as well. So these are all the scenarios with the same technology that we can pursue today. And that, in a nutshell and very quickly, is my presentation. So I'll pass it back to you, Dan.
Great, thank you, Edson. That's terrific. I didn't have any questions for you. I had a dozen questions going through my head. That was a very rich presentation. Appreciate it. Maybe as I start through this transition, if there are any questions for Edson, please go ahead and type them into our chat function. And then Doug Staker from Carbon Quest, you've got the little green share screen button down there at the bottom. And we'll look forward to hearing from you. There you are. We see you. Are you audio on there, Doug, or are you muted?
There we go.
There
Yes.
you go.
Trying to find the unmute button. So,
okay.
Thank you very much. Thanks for taking some time today. Very interesting presentations ahead of time. Edson, I think you'll be interested in what we're doing because we're actually using ZBEC technology. So very interesting coincidence. So thanks again, Dan and group, for the opportunity. My name is Doug Staker. I'm the Vice President of Business Development for a company called Carbon Quest. And we are focused in how do we provide decarbonization for large buildings starting in New York City. A little bit about the team that I work with. We're a group of problem solvers that have worked together across 3 different companies over the past 30 years. Our last company, we built and pioneered battery energy storage that was deployed into large buildings in New York City. And we learned a lot in that process, got to know the city very well. And as pioneers, you know, you walk around very happily with a lot of arrows stuck in your back, and you learn from those experiences. And so we've learned a lot. And what we see today is not only is there interesting regulation in New York City about reducing greenhouse gas emissions, there's also a strong focus corporately. A lot of the buildings that we did work in and owners that we know that own buildings in New York City have just a personal mission to do what they can to help remove greenhouse gases. So it's a very interesting area to start building a business in. We're pretty comfortable with it, but it comes with its own set of challenges. So one of the things that is interesting about New York City is that about 70% of the greenhouse gas emissions in the city come from the buildings. And there's a law that was enacted a couple of years ago known as Local Law 97 that requires buildings over 25,000 square feet to be limited by the amount of greenhouse gas emissions that they can emit, CO2, fundamentally. And out of that select stock of buildings over 25,000 square feet, they're responsible for 42% of the city's emissions. So when you have goals like New York City has, as far as 40% by 2030, they've actually moved that up to 70% by 2030 and 80 by 50. We've got to figure out how to use every tool that we can think of to help develop carbon dioxide emissions, reduce emissions. So a lot of these buildings use natural gas for heat primarily. New York City is very interesting in that the heat load is about 3 times the energy of what the air conditioning load is. And this is where the challenge is in the city, is that when you look at what Con Ed has to do to be able to deliver enough electricity to handle the cooling load in the summer, to think that they were going to migrate over to an all-electric heating load would be very problematic. It would add about 3 gigawatts of electricity load onto a grid that already struggles to deliver what it does today. So there's some challenges with the whole beneficial electrification, especially these large buildings. And just the efficiency of a gas boiler system is just hard to beat with an electric product. So there's, for building owners that are subject under this local law, it is a challenge in that they are taxed both on the amount of electricity they use and the amount of natural gas they use, using constants that have been set into the law as far as what the emission rate is for a therm of natural gas and what's the emission rate for a kilowatt hour of electricity. And certain buildings, there is about 10 classifications of buildings that get various limits based upon the square foot of the building on what's their allowable limit. And I have some detail a little deeper here in the deck that'll show you how the mechanics work around this law. It's tiered and it goes into effect by 2024, steps up in 2030, and then again in 2035. So when we look at carbon capture technology, as Edson pointed out, carbon capture technology has been around for a while. A lot of it's used at a larger scale. There's about 40 million tons of different types of capture systems that are collected around the world. There's about 51 projects in operation or under construction. There's 10 in North America. And it's really becoming a large market, because what we're hearing more and more, to be able to achieve the targets that everyone's looking for as far as greenhouse gas reduction, we just have to figure out how to do everything to reduce carbon emissions. And so our trick, what we're trying to do, it's something that we learned from the battery side of the business, is that we're trying to take this technology and scale it down for in-building installations. If I had $1 for every time somebody tried to explain to me that there's no room in these buildings in New York City for this equipment, I would just say, I beg to differ. I've been through a lot of buildings, and there's a lot of room. You just need to know where to look and how to apply it. So the types of buildings that we go after, this is where we're building our first system. It will be installed in January of this year. This is a multifamily high-rise building up across from the Lincoln Center up on Broadway. This building uses natural gas for heating and for hot water. It doesn't use natural gas for absorptive chilling, but there's quite a few buildings in the building stock in the city that do use gas for cooling as well. So when we look at opportunities, these are ideal applications, and also where we just have corporations or building owners that are looking to decarbonize. It's a pretty common goal for a lot of these corporations under their whole ES&G culture to look at what can they do to improve the environment. The owner of this building, their belief is they can't just be the problem, they've got to be part of the solution. And so what we've put together, we think is economical. It's got a low CapEx perspective. It's safe from installing systems in a building. It's modular. We can take and size this up and down based upon the usage in the building. And more importantly, is it's measurable. So we're able to measure the carbon that we're capturing and liquefying and then transporting out. I'll go through that here on this slide. So what we do is we attach to the flue from the boiler systems, and we divert and we size our system to be able to optimize production based upon just the range of operation of the boiler systems. The first stage, we go through a condensing and a cooling phase, where we'll cool it to draw out the liquid in the exhaust there. So pull the water vapor out and liquefy it. And then we'll take that dry gas, we'll move it over into the separation and purification stage, where we'll first compress it, and then we'll run it again through another dryer, a heatless dryer, and then we'll run it into a pressure swing adsorption system. This happens to be a system produced by Zeebeck, who bought the company that Edson helped found earlier. So it was a very interesting coincidence that we're on this session together, Edson. And then from the PSA, it does the gas separation, where the remaining oxygen and nitrogen is put back into the flue. The CO2 is passed over into the liquefaction phase, which is again a series of compression and cooling, and stored into a vacuum jacketed tank that gets further cooling and stored. And then we will produce at peak heating season at this first building about 3 tons of carbon dioxide about every 2 days. So we will pump it up to trucks. We have been working with off-takers to take the CO2 to be used in various applications that will sequester the CO2 as far as its application and use. When people like to educate me that you don't quite understand, there's no room for this stuff. This is an example of a room adjacent to the boiler room that we're going to be using. This takes up, it's currently in a parking garage. It takes up about 4 parking spaces. It's got, you can see we've got the diversion pieces there. We've got the compressor, the dryer, the PSA, compression skid, and the liquid nitrogen tank. So that's one of the challenges on how do you lay out and put these systems in buildings. This picture here on the right is our lab where we're building the system and testing the system, based here in Spokane, Washington. We're getting it ready to ship. We're going through some final testing, and we'll ship it in late December and start installing in January. When you look at the issues around how do buildings decarbonize in New York City, again, this is almost a 400,000 square foot building. It's got 229 apartments. It's got a retail business in there, a Bed Bath & Beyond, and a couple of restaurants. But the building owner is subject for all the energy usage in the building. Even though the apartment owners pay for their own electricity, it's not included in the rent. The building owner is going to be taxed for the electricity usage and the equivalent carbon that's emitted based upon that electricity. So when you look at a building like this building in particular, about 45% of the energy that they use comes from, or the CO2 that they produce comes from natural gas. The other 55% comes from the electricity. They are limited starting in 2024 to only emit 2,500 metric tons of CO2. But this building currently in operation will emit about 2,900. So they're about 400 metric tons over their limit. That transforms into a penalty that will equal about $97,000 for the first 5 years from 2024 to 2029. The value of carbon in this whole local law is $268 per metric ton, which I find interesting in that in a lot of areas, people are talking about what's the true cost of carbon, what's carbon trading at, where is it in the market somewhere right now. And in most cases, it's about $15 a ton. And people are talking about migrating it to $50 a ton. But for New York City to tax the excess amount that you use at $268 a ton, some people call it a carrot, some people call it a stick. But all I know is that it's very effective. And so for this building, as far as what they would be able to do is we will be able to reduce their overall carbon emissions by about 25%. By just capturing CO2 from the exhaust gas of their boiler operation. So looks very beneficial for these buildings. This building just doesn't have an opportunity to do an electric conversion. There's lots of people discussing about using heat pumps into buildings like that. There's a lot of physical aspects around doing that. There's electrical wiring aspects why that's challenging, the electrical service, and just the fact that it will be a challenge for Con Ed to grow that electrical network to handle that increase in load over that time frame. So as an alternative and a way to continue to use the efficiency of natural gas in the system, we think that our approach is going to help these guys be successful. Once we capture the CO2 and pump that out, we are working with local off-takers. We have a group out in Brooklyn who happens to be a supplier to our customer, the building owner, for blocks of bricks. And they use the carbon cure system to inject CO2 into the mix of concrete for the block and brick production. And that permanently transforms the CO2 into calcium carbonate, a great sequestration strategy. We actually are working with Con Ed that uses CO2 in wastewater treatment at one of their steam plants where they take the CO2, and when you inject CO2 into waste streams, again, it acts as a neutralizer and helps balance out the pH in wastewater. So there's a good opportunity to utilize some of the CO2 we're producing to help solve that problem as well. We're very interested in the aquaculture markets that are developing. There's a company in Canada, Quantec, that develops bioreactors that use CO2 to create algae. And there's a wide variety of markets for algae around the world. And then agriculturally, using CO2 in greenhouses has proven very effective as far as performance and improving greenhouse gas greenhouse growth production by using CO2 for operations. So good opportunities to take and transform that CO2 that we capture and put it into new emerging markets as well. So that's what we've got. That's what we're up to. And I look forward to your questions. Thank you very much.
Well, Doug, I have one, and that is, so the application for Carbon Quest is currently is in large commercial or multifamily residential buildings, New York City. Obviously, we have some of those out here, maybe not as densely built as in New York City, but are there other opportunities beyond the building sector? So I think of industrial applications or even say compression, natural gas compression facilities and the like. You know, are there applications like that for Carbon Quest technology?
You know, there are applications. And as a matter of fact, we have been out working with one of the local transmission companies here, gas pipeline just south of town here. And we walked through their facility to understand their usage. And what it boils down to is when you look at the opportunity as far as monetizing the CO2 sequestration, it's just a matter of economics. That's why New York is very lucrative right now based upon that structure. It's hard to do today unless there are other economic drivers just to base it on the offtake value of that CO2. So you need a little extra kick if it's some of the 45Q tax potential that's out there. But we do think other markets will evolve, and we're just focused in New York because that's where the incentives are in place that will allow us to expand and grow rapidly while other markets mature. We're seeing actually some interest in Tokyo as well. But do think that there's areas in the Northwest where this could be applied and beneficial for carbon sequestration.
Mm-hmm. Great. I have a question for all three panelists that from Dave Stanton of Northwest Natural. His question is, how can the gas utilities in the region provide the most meaningful support for technologies and entrepreneurs? What other, and then the second part of the question is, what other entities have helped bring your technologies to market? So Doug, while we have you up on the screen, why don't we start with you, and then Edson will come to you to answer the question, and then we'll finish up with Rita on that one.
Well, utilities are in a great position because they just have the customer relationships, right? And so they know what customers they have out there that have challenges that they're trying to solve. So we like working with utilities because they know their customers fairly well, and they know who would be interested or who have they been in discussions with as far as applying some of this technology. So I think it's a great opportunity to work with them and help them solve some of their customers' challenges.
And then the second part of the question is, what other kinds of entities have come in to support commercialization of your technology?
Well, I think what's important as far as getting the regulators involved as well. Utilities are ran by regulation, and so that regulators understand the opportunities that these three technologies that were presented to you today, how those apply into an evolving market. I like how Rita pointed out, and both Edson pointed out, the number of jobs that are associated around that. And so really getting regulators aware and on board with what these technologies can do, I think is very beneficial as well.
Great, thank you. Edson?
Gas utilities as a partner is critical for our success and the industry's success, primarily because they foresee mandates or have internal objectives to have more and more renewable content to be put into their grid and available to end users. That simplifies things for us because then we really only have one customer. We make a large amount of RNG and sell it to one customer who takes care of all the distribution and end client contracts. How they help us is ideally they would one, provide the offtake agreements that gives us sort of the revenue stream that you can use to get financing and investment on own and operate of an RNG plant. As I mentioned, our scale of plants is in the sort of 20 to 150 million type range. So these are not minor numbers. And the payback takes quite a while. So it's not a venture capital type of sector to be involved in. So the second part would be to have gas utilities participate with us in own and operate of these plants to provide the gas that they're looking for. And by doing that, they're a source of patient capital that has a vested interest in our success. They also have the ability to access lower cost financing for these large plants. And together we can pursue some of the grant funding opportunities from the various levels of industry and government funding, which helps offset some of the risk of the initial commercial plant. So that's really critical, is to go out and get some of the grant funding. Not that there's risk in the technology failing, but first off, in a large commercial plant, there's going to be whether it's delays or things that need to be adjusted and tweaked or rebuilt. These are large expenses that you really do need to have partners that have the size and presence that gas utility offers.
I appreciated your term about patient capital. That's a good one. Rita.
Wow, I don't even know how to add to what Edson just talked about, because it's all what he says is just spot on. I mean, we have found, fortunately for us, half of our revenues have already come from utilities. So to be able to just, as we are always, as a CEO, always fundraising, it's really, really, really critical to be able to show, hey, we have penetrated these fortresses of natural gas utilities and found early adopters like as patient capital, people who want to work with us within. Every utility comes with their own unique set of procedures and way they do things, and multiple disciplines within a utility. Sometimes, what we're finding is now we're trying to interact with the operations side, because we now know that our tool can be used for pipeline evacuation during repair and maintenance of distribution lines. So finding the right entities within these utility organizations is much easier once you've established that relationship. We would not be anywhere where we are without the support of Northwest Natural, for example. And now all the other, I was just doing a list of like the 6 other utilities that we're now engaged with, going into Canada with our utility partner up there with the help of CSA and Arcan to get into these entities. So when Dave's asking about what other entities, it is organizations like the regulatory folks that was mentioned earlier, other non-dilutive funding sources, because let's face it, when you're in the world of hardware, energy, this is they now have new terms: hard tech, carbon tech, whatever you want to call it. We're not an app on a phone, so this is not low capex.
Right.
That standard VC capital is putting money into. This is hardware solutions that's going to make a difference. We're solving real world problems here, but yet trying to grow these homegrown innovations on a shoestring budget and bootstrapping can be, it's hard. And without people like Northwest Natural, you're not going to find these innovations at least grow beyond their 4th, 5th, 6th valley of death, because it requires capital, and it requires a very specific kind of capital.
Right.
So
right.
Anyway, go. Great question, and we're just grateful for even, we've had I don't know, I think there was somebody I saw earlier, we've had one of the local, not local, but one of the national tube trailers is coming to the table as a partner. We have oil and gas sites coming to the table. We have dairy operators coming to the table. So we need all of it. And we're just grateful to be up here in the Pacific Northwest with such a rich ecosystem.
Great. Well, on that, we always try to pledge to finish on time, but I just want to thank each of our presenters. And Edson and Doug and Rita, thank you so much for your time today. And thanks for investing your lives in these technologies. I'm really excited. I mean, so we have a technology that is being, it's born and being grown in Burnaby, British Columbia, one that was born and is being grown in Bend, Oregon, and one that is born and being grown in Spokane, Washington. And each of these technologies, in the context of our region's environmental ethic, promises to help the 128,000 miles of installed energy delivery infrastructure that we have in the Northwest continue to contribute to our clean energy objectives in the region. And so thank you, three, and thank you all who've joined us today. Once again, we recorded this YouTube video. This webinar, it'll be on our YouTube channel probably by tomorrow. So you're welcome to look it up there. If you want slide decks, please contact me and I'll forward your contact information along. And we can, we'll let you interact directly with the presenters. So with that, I wish you all a great Thursday, rest of your Thursday afternoon and weekend in front of you, and a wonderful U.S. Thanksgiving. I think you guys have already had Thanksgiving up in Canada, right, Edson?
Yeah, I have my fill.
Okay, good. So thank you all very much. Have a great day.
Thanks,
Thank
Dan.
you.
Thanks, everyone.
Bye-bye.